Okay, so let's start again. Welcome. We are very pleased to have you today for the number 21 of the networking channel program. Gratitude to Raymond from EURECOM, who very gently has organized this program. It fits perfectly with the spirit of the networking channel. It is addressing a technical topic, but also a topic, a project that is of importance for the dialogue with the society and hopefully to the benefit of the citizen. So we are very pleased to have this edition dealing with Magma. And, this is the program for today. Magma, current focus and road ahead for 5G. Raymond is the chair, and we are very pleased to have Amar and Tien on board. So I hand over right away to Raymond. And again, thank you for organizing this channel and for participating.
Okay, so thank you very much, Serge. I hope everybody can hear me okay. You know, when Serge expressed interest in hearing about Magma, I thought it was a good it was a good idea. I mean, Magma is a piece of software that we've been using at EURECOM and contributing to over quite a few years at this point. We've been working with Amar's team when he was at Facebook before, from the very beginnings in this. And it's something that is actually going to continue in the next few years. So I thought it would be good to look at one of the key architect, which is Amar, who will introduce himself too, I hope. And then Tien from EURECOM was contributing more recently in the 5G space, who will also talk about how at least we see the evolution of this software when it comes to 5G. So without further ado, I'd like to hand it over to Amar. And if you could introduce yourself a little bit too at the beginning, that'd be great.
Yeah, perfect. Thanks a lot, Raymond and Serge. So a quick introduction. So I'm Amar Padmanabhan. I'm the founding engineer on the Magma project, but calling myself a founding engineer is incorrect in the sense that a lot of the work in Magma is based on the excellent work that EURECOM and the Open Software Alliance did with the 4G core that we used as its like sort of initial seed code to build the project. So I'm sort of the original engineer from Facebook who took the project and built out the Magma project. So a lot of history behind the project is that it started roughly 6 years ago, and Facebook was primarily focused on bringing more people online in emerging markets. And a big driver for a lot of the design that we have is from the way Facebook operated its data center and to reduce like sort of the cost of entry to 3GPP networks. So a big focus of my talk is going to be around the principles that we've sort of employed that we, I would say were inspired by what happened on the data center side to introduce like low-cost networks and thus reduce the barrier for entry in 3GPP networks as well. So I'm going to start sharing, and a quick shout out to Bruce Davey as well, who is one of the Magma Foundation TAC members. He also helped like put together this content. Cool. So today I'm going to talk about the cloud native principles to approaching 3GPP networks. And we start with the assumption that a lot of the benefits that the hyperscalers have had from the cost reduction on operating their data center networks was due to the ability to run cloud native networks on like commodity hardware. And that's why, Facebook, Google, Amazon, and all of these large networking operators have the cost structure that they do compared to like traditional like data center operators from like 20 years ago. So, so that is sort of the thesis behind the project Magma here. So Magma's mission is to help service providers build cost-effective, extensible, and carrier-grade networks And this was primarily motivated by Facebook's need to help people, especially in emerging markets, come online, and indirectly also benefit Facebook itself, because they leverage a bunch of the Facebook products like Facebook, WhatsApp, Instagram, and that requires broadband access. So the key challenge of connecting a lot of these networks is the problem of heterogeneity. So there's a problem of heterogeneity in terms of scale. Like there are operators in Brazil who leverage Magma, for example, who have 2 or 3 like sort of site deployments in the Amazon area. And then there are operators in like rural like US who have like hundreds of sites. So there is a big problem in terms of scale. There's a big problem in terms of managing heterogeneity around backhaul. Like there are satellite-based deployments, there are like microwave-based deployments, there are fiber-based deployments, and all of these have very different network characteristics. There's also heterogeneity in terms of access technologies. In certain cases, people are using LTE. In certain other cases, they're using CBRS, which is a lightly licensed band in the US. Then there are Wi-Fi deployments, and now I think even what Tien is going to talk about is like the upcoming 5G sort of support in the Magma core. And then lastly, there are very different business models. Like one very interesting use case for Magma is this decentralized network from Helium, which is a fully federated sort of neutral host network that Dish has sort of signed an agreement with. And so enabling all of these different sort of business models is also a key sort of driving force behind the project. As it's not just technology unlocking, it's also like unlocking a new set of business models. So the underlying thesis behind all of this is that there's a lot of heterogeneity in terms of like network architectures out there to address the next billion user sort of problem. So it's been a long time since the computer revolution started, and almost all of these industries have like fundamentally transformed. And there's a famous quote from Mark Andreessen which says, "Software is eating the world." But given all of this, such a transformation hasn't actually happened on the 3GPP network side. Why hasn't this happened, right? Like the big transformation that, oops, sorry. It's not going back. Okay, so the big transformation that has not happened is that, the mobile networks still look like the networks that were there 10, 15 years ago, in the sense that there are these base stations, they all send back traffic into these large, like, refrigerator-sized devices that are core networks, and then, packets egress into these core networks. Sorry, I'm just going to try to fix my display 1 second. Yeah. So, so all of these challenges make it very monolithic, and it is not like the cloud native way of like breaking up the network architecture into various different smaller pieces. Software-defined networking was a big effort that became popular in about 12 years ago, and most of it was driven by the revolution on the data center side with like virtualization. So networking historically has evolved in service of workloads, and as virtual machines started happening, the network needed to itself be a lot more programmable. And as there was the emergence of a new kind of compute workload, which is the virtual machine, the network needed to evolve, and software-defined networking was born. So what happened on the data center side, and if you like peek into like a Facebook data center, a lot of this looks similar, is that in 2010-12 we had these large middle boxes in Facebook that were like firewalls and load balancers, and then those sort of transitioned into a software-based commodity hardware reliant sort of network platform, right? So if you look into like the load balancers in Facebook today versus 10 years ago, almost all of that is running on generic compute or like merchant silicon. So this transformation happened on the data center side, where we went from a physical to a virtual network. But the transition from 4G to 5G actually looks pretty similar, right? Like we just replaced the number of boxes on the core and moved some of the UPF functionality to the edge. But at the end of the day, the devices are still fairly large and fairly centralized, and there was no like sort of virtualization abstraction that was built for enabling SDN, right? So that is a transition that didn't happen on the 3GPP side. So the 5G architecture, while it is still a little distributed, is fundamentally still edge-centric in the sense it's not pushing traffic to small pops and micro pops like the data center architecture has done, and is only moving some of the UPF functionality on the 5G side to the edge. So this transition of a full-blown network platform where applications or network functions get instantiated anywhere in the network hasn't happened. It's still bespoke devices that are like topologically relevant locations. So the big reason, at least according to us, is that there is the leaky abstraction problem with 3GPP networks. Like depending on the radio technology you use, the rest of the network architecture is sort of determined based on the radio technology it is used. So what we're arguing for here is that if you had better abstractions in the 3GPP network, you could build more of a composable or runtime instantiable variation of a 3GPP network. And that's a lot of the motivation behind Magma. In fact, the single largest design decision I would say that we made in Magma is to terminate all of the 3GPP protocols at the edge as close to the radio as possible, and then have a generic model for representing subscribers and accounting, authorization, and various other components across the different radio technologies that get deployed. So a key part of the SDN architecture is the separation of control plane into something that is logically centralized, and then that programs the data plane. And this is you would see this as a recurring theme in the Magma architecture, where we have a logically centralized control plane that then programs a bunch of devices. Because if you take the model of a data center, the fact that some large devices got broken into hundreds of smaller devices introduced the need for operational simplification by creating this logically centralized management and control plane. So you're not actually having to deal with the abstraction of hundreds of these gateway devices that are sitting everywhere in the network. So a quick, translating these abstract ideas into a few design points that we tried to re-emphasize in the Magma architecture. So the first one is, how is Magma similar to the canonical SDN architecture, right? So Magma has this component called an orchestrator, and this orchestrator is where this orchestrator offers the user the ability to interact with the network, and it offers a single pane of glass, operate and monitor the network. And then there are these distributed devices that are sitting at the edge of the networks. In fact, access gateways are typically co-located with the radio itself, and in some cases, maybe just a board within the radio. And the logically centralized management is sort of abstracting away the complexity of these hundreds of devices. So while a lot of existing 3GPP networks focus on the protocol aspects of networking, a big focus of the Magma project is on the operational aspects of networking, right? So we offer alerting, configuration, all of that using modern cloud native tools like Kubernetes and Prometheus and Elastic and Logstash out of the box. So this, we think, is a fairly fundamental part of the transition that data center networks made, especially in the hyperscalers. The second thing just to highlight here is that the interfaces towards the outside components that are not like that help us help Magma interoperate with existing networks are standards based. But by terminating all of these standards at the edge, we have these unified implementations across, say, Wi-Fi and LTE that can that don't require like standing up an entirely new say Magma instance to support both carrier Wi-Fi and LTE and now 5G as well. The second one is the heterogeneous edge. This is again a thing that we directly borrowed from some of the hyperscaler, and that Google had a paper in probably like 2009 with Andromeda, where they introduced a layer of abstraction at the edge, and that helps sort of insulate the heterogeneity of the devices from the centralized sort of control plane. As much as possible, you do data normalization at the edge. And so you build and operate one network and have the edge absorb the heterogeneity so it doesn't bleed through the entire network. And I would argue that this is probably the most fundamental decision that we made at the inception of Magma that has helped us support all of these heterogeneous use cases, because heterogeneity is complexity. And as long as you can insulate your system from that complexity, you have the ability to support like, varying different business cases, scale, all of these other aspects. The last one, which is kind of underemphasized, but is also pretty critical, is that, Magma is built on production grade, like sort of open source technology components. I did mention the OAI EPC that we started with, but there are other components. For example, in the orchestrator, we use Elastic and Kibana, Fluentd for log exporting, Prometheus for metrics. There's a proposal to migrate Prometheus to Victoria metrics. There's Kubernetes, there's Postgres. All of these are production hardened open source technologies. So a key principle that we have is that, we layer our innovation in an open way, as opposed to like, building things from scratch. A great example is Prometheus, right? So Prometheus served us well. It was great. And it was probably the best time series implementation out there 5 years ago, but now there is Victoria metrics and a few other innovations around Prometheus itself. And the fact that, Magma embraces open source so well helps us, upgrade the existing orchestrator infrastructure from Prometheus to, say, Victoria metrics or any other newer technologies. The last one, which is more on the operational aspects of the network itself, is that upgradability, right? The cornerstone of the software is going to eat the world principle is actually the supply chain disruption that happened because of that. And upgradability needs to be a first-class concept. So, we're not designing for features that are unknown, that we don't fully have an understanding on the market demand around, but we are actually designing features for what is currently required, and then have enough upgradability built into the system that we can sort of adapt our, adapt our roadmap depending on the needs. So a great example is the MME project, right? So the MME part of the project, which is the access abstraction, only supported 4G. A software upgrade basically allowed us to start supporting 5G on the same access gateways without having to redo the entire sort of deployment. And also componentizing these services in a sort of access agnostic way helps us upgrade individual components. Like session management added SMF functionality, and that was again enabled through a software upgrade. Cool. So just going through the history of Magma. So the original use case that Magma was focused on was fixed wireless access. This was where our rural sort of partners were focused on. Then we started focusing on Wi-Fi access. Again, this is to allow seamless migration between LTE and or like SIM-based networks and Wi-Fi networks. This allowed us to expand into areas where spectrum, especially in Asia, where spectrum was hard to come by, and the 3G networks were keeling over, and this allowed us a way to sort of augment capacity on the network. Private LTE is something that just happened because of our small form factor. This was not a primary focus, but just the fact that the system was composable enough allowed us to address some of the private LTE use cases. I think in the Magma Foundation, there are about 15 startups that are primarily focused on private LTE at this point. Network expansion, this is where we've seen some early success, and Helium is a phenomenal business model for proving out this model. But the idea there is that Magma is a neutral host network, and operators that want to expand their network are able to tap into this new sort of neutral host network. The other sort of interesting side effect of this is that because these network expansions allow for heterogeneous devices at the edge that don't talk back to existing carrier cores, we are seeing a lot of innovation in terms of the new RANs that are getting deployed. Some of the price points that we're seeing out in the market, at least in the US, is some of the 10-watt units that we're seeing are going for $600, which at this point is kind of comparable to enterprise Wi-Fi solutions. So an indirect side effect of our ability to abstract the complexity at the edge is that we're also helping push down the cost of the RAN that is getting deployed. Lastly, and I think Tien is going to cover this in much greater detail, is the evolving roadmap to support 5G, and in specific mobility for 4G as well, full mobility between access gateways. And this would be the focus of our roadmap over the next year or so. I think this was the published roadmap. Not all of this is still, sorry, the dates are a little off, but yeah, this was the published roadmap from probably the last time the Magma Foundation published things, which was earlier this year. But the focus has now shifted from 4G only to 4G and 5G, and Tien is going to cover some of this right after. So to summarize, I think the three key principles that Magma tries to address to lower the cost of barrier to entry is the ability to address heterogeneity, be it with scale, access technologies, backhaul, or business models. The second one is we want to adopt innovative technologies, and a lot of this is leveraging existing open source technologies and opening the ecosystem. For example, a lot of what we build on the orchestrator side is reliant on the Kubernetes ecosystem, and a lot of what we're doing on the 4G and 5G, the 3GPP side, is in partnership with EURECOM and other organizations. So we would like to absorb any new innovation that's happening in the market. And then the third one is we're looking to scale. So our largest network today is the Helium network, which has about 5,000 odd radios. We're looking to scale, and by distributing the compute at the edge, we think we have the right architecture to scale. Thanks. That's all I had. So I'll stop sharing now and pass on the presentation to Tien.
Okay, thank you very much, Amar. For those in the audience, if you want to ask questions to what Amar just presented, I think you can, as Serge said at the beginning, you can do that in the chat. So now I'll pass it over to Tien, and if you can introduce yourself quickly too, that'd be great.
Okay, thanks Raymond for the introduction. Good morning, good afternoon. My name is Tien-Thinh Nguyen. I'm a senior researcher at the EURECOM, and I'm actually leading the 5G Core Network activity at EURECOM and Open Interface Software Alliance. So I'm very happy to be here today to talk about the Open Interface contribution to Magma. So let me share my screen. So can you see my screen now?
Yeah, that's fine.
Okay. So first, thanks to Amar, we already understand the main architecture of the Magma. So first, I will start with a brief introduction to OAI, and then we mention the historic relation between OAI and Magma and the main contribution of the OAI team to the Magma project. I will then talk about the proposal to hand over the testing and CI from Magma Foundation to OAI. And finally, I will give a brief update on the current implementation status of OAI 5G core network and the plan to integrate OAI 5G core network into Magma architecture. So first, just a few words on the open interface. For some of you who are not familiar with OAI, so OAI is a flexible platform to enable an open source 4G and 5G ecosystem. The platform offers an open source software-based implementation of a subset of a 4G and 5G system. So it covers the full protocol stack of the 3GPP standard in both RAN and core network. So for example, for the RAN part, we have OAI eNode B, we have OAI gNode B with a monolithic and CUDU split option for 5G, and also we have a simulated UE. We also have an implementation of 4G EPC, which then updated to support 5G non-standalone mode. And this 4G EPC is actually the heart of Magma EPC that we mentioned in a couple of minutes. And we also have an implementation for the 5G core network in standalone mode that we want to integrate into Magma ecosystem. And then to facilitate the OpenAI interface adoption, the OAI Software Alliance was launched in 2014 by EURECOM, and the objectives were to promote OAI and its open source licensing model, and secondly, to support the community member and also to accept the donation to maintain the engineering support team. And currently we have a nice strategic member such as Fujitsu, you can see here in the slide. Fujitsu, Qualcomm, and Meta, just name a few, and a lot of associate members. Actually, our host today, Raymond, has been serving as president of the OSI since December 2018. Now about OAI contribution to Magma. So as mentioned earlier, back then in 2016, Magma was built with the centerpiece of from the OAI MME. So and the last upstream push from Magma to OpenAI CN were in 2017. And from then, while Magma were focusing on the hardening part of the code, OAI keep adding the new 3GPP features with the main target to work the cloud native support and fully 3GPP compatible. And in 2019, the Converge MME project was launched to bring together the contribution from both communities. And since then, OAI team continue to work on Magma to bring 3GPP feature to the project. For example, to support S6A, S11 interface, and also to bring 5G NSA, NTM, and BIoT to Magma and continue to help to optimize the code base. OAI also contribute to Magma CI, however, use a container instead of the virtual machine for the core network services. And we also validated Magma MME with a third-party tester. And I would like to mention here that for the 5G SA part, due to the conflict in the licensing model, the OAI team couldn't directly contribute to the Magma code base. However, we still participate in the designing phase and continue to help the Magma team to fix some issue, particularly related to the NAS and NGAP protocol for 5G. Recently, for the Magma and testing and CI, recently OAI submitted a proposal to hand over the testing and CI from Magma Foundation to OAI, and this proposal have been accepted by the Magma TSC, and now waiting for the final approval from the Magma Board of Directors. So the duration of this project will be in 2 years, which includes several milestones. So in brief, in this proposal, we propose to not only take charge of the maintaining the existing testing framework, but also extending it with additional feature for both 4G and 5G. We also try to cover some important but still missing points to further facilitate the adoption of Magma by the community member, such as containerizing Magma component with Docker and Kubernetes. I don't want to go into too more detail of this proposal, but just want to highlight some important points. For example, as an open source software only framework, we would like to use existing open source run simulator, including OAI, eNodeB, gNodeB, to test with 4G and 5G. And for the 5G SA, we also plan to test Magma Access Gateway with OAI 5G core network component via the Federation Gateway. It's actually a part of the integration plan between OAI and Magma that we will talk in the next couple of slides. And then we also plan to implement a brand new open source framework, which include a 5G core network tester. This new 5G core network tester is a kind of NGAP line tester, and is a part of an extensive framework and can provide a wide range of test cases. For example, it can be used to test basic procedure with multiple UE and multiple PDO section in the loop, or to test some advanced scenarios such as handover, timer handling, and particularly to support negative testing scenario. We also provide all the documents related to implementation, testing, and deployment so that the community can replicate and use the tool easily. Then we have another group of the tasks focusing on development of Magma component, first to maintain the current deployment framework, but also adding support for Docker and Kubernetes. We also plan to extend CI framework to accommodate the new testing scenario and expand to pre-test, pre-commit test pipeline. And finally, we will collaborate with other partners, including ARM, to port all Magma ecosystem to ARM architecture with container. So before going into the plan to integrate OAI core network into Magma architecture, just take a quick look at the current implementation status of our OAI 5G core network project. So the goal of this project is to provide a fully 3GPP compliant 5G core in standalone mode implementation with a rich feature set. So you can see here that the OAI 5G core network is designed and implemented in a flexible way so that it can be easily adapted to satisfy the need of different 5G use cases. At this start, we have I would say that we have a solid and functional 5G core network. It can support basic procedure with multiple UE and multiple PDU section, of course. And it also supports some advanced features such as network function registration and discovery, and to hand over HTTP version 2 and FQDA and network slicing. FQDN and together with the network registration and discovery, we lay a foundation for deploying OAI 5G core network in a cloud-native environment. And we also implemented even exposure services to explore internal 5G core network information to the third-party application and provide a very basic support for private 5G network. So from the beginning of the OAI 5G core network project, we always thought that stability, flexibility, and simplicity are the key for the adoption of OAI 5G core network. So with that in mind, we built OAI 5G in such a way so that it can be easily adapted to different use cases. For example, we provide different options to deploy 5G core network, and the same for user plane with different possibility for the UPF. We also provide different approaches to deploy our core network, ranging from a traditional to a more cloud-native friendly approach. For example, we provide a cloud-friendly deployment based on Docker Compose, and also deployed in an OpenShift cluster with Helmchat at EURECOM premise. And then to warranty the quality of the implementation, all the implemented features are continuously tested with a professional tester and commercial GNodeB with Ghost EV, and also with simulated EV and open source run simulator as well. So with this OAI 5G core network implementation, we plan to integrate OAI into Magma project. The main idea is to give the community access to complementary and 3GPP compliant network component, so that it can help to increase the feature coverage and the adoption of the Magma by the community. There are two integration plans. You can see here is the first one, is to integrate some component from OAI 5G core network that do not exist in Magma. And in this case, OAI 5G core network can be considered as a third-party 3GPP compliant 5G core and connect to the Magma core via the Federation Gateway. There are several advantages of this integration plan. For example, first, to bring some more network function to a Magma ecosystem, and also provide a common framework to translate from Magma gRPC-based interfaces to the standardized 3GPP SBI interfaces. And then it's also allow testing Magma 5G component with another third-party 3GPP compliant component. And finally, it also provide some advanced 3GPP compatible features, such as even exposure API or network slicing. And the second integration plan is to make the entire 5G core network component available to the Magma community by integrating OAI 5G core network directly in the Magma architecture. So you can see here via the orchestrator. The OAI core network will sit alongside the Magma access gateway. By doing so, we can bring to the community the advantage of both the OAI core network and Magma orchestrator. And the idea is we will build an orchestrator gateway sitting on top of the OAI core network. This gateway we translate from the orchestrator gRPC core to the OAI API to configure and collect the corresponding information from the OAI 5G network function. By doing that, from the orchestrator point of view, OAI core network can be seen as similar to the Magma core instance. We can highlight here some main advantage for this. For example, it gives more freedom to choice and more feature for the community. So maybe increase the adoption of Magma And we also can take some advantage directly from the OEI 5G core network at crowd-friendly deployment, fully 2GPP compatible, and also with a clear separation between the network component. It makes the code base easy to contribute. And the other advantage of the second integration plan in comparison with the first one is we don't need to do any modification or update to the Magma core, so that it can reduce the significant amount of work may require to update the Magma core to accommodate 3GPP compliant 5G core network. So with that, I conclude my presentation and happy to take the question and give back the floor to Raymond and Amar.
Okay, thank you, Tien. So at this point, we don't really have any questions in the chat, so I hope people are thinking about questions here. Maybe I can start with one. Probably targeted to Amar because it's historical also with respect to Magma. If you look at some of the other projects, like some that were in ONF and doing similar things but in a different spirit, there was quite a bit of interest from operators, like 3GPP operators. We're starting to see that a little bit now, especially with Helium. What is the way really to to increase the uptake with some of the big operators?
Yeah, no, that's a good question. So I think the primary driver that we had focused on with Magma is to sort of solve a part of the puzzle that's not addressed by sort of the traditional MNOs, right? So the way that Bruce Davey, who is on the Magma Foundation, talks about it is like Magma is trying to fill the gap between Wi-Fi and LTE or like cellular, right? It's trying to make 3GPP networks as simple as Wi-Fi networks to deploy. And the way that I think that transition is going to play out is actually in cases where the network needs to be built as a combination of tops-down macro networks and bottoms-up like sort of small cell networks. And with the growth of like mid-band spectrum and like Wi-Fi 6 and all of these things which have like very poor propagation characteristics, there's going to be a lot more small cells that are getting deployed, or like like topologically relevant sort of radios. And at that point, the existing carrier deployment models of like, oh, let me go buy a large tower that's going to cover like tens of kilometers won't work, because the propagation characteristics just won't work for anything beyond mid-band. So I think like Helium is just the tip of the iceberg. I think Helium just made the business model more reasonable for like people to deploy a conjunction of bottoms up sort of small cell networks and tops down macro networks. I feel as that model grows, we'll see a lot more deployments of Magma. So as 5G takes off, I think it may actually help us.
Well, I hope so too. So there are a couple of questions here. I'll try and read them out. So there's one here from Jim Quiroz. Thanks for the great talk. You said earlier that radio technology specific control is terminated close to the radio. Could you give an example of, say, for LTE 5G Wi-Fi implementation of user authentication, which still must be performed by the MME HSS, AMF, or radius servers provided by a third party? Magma thus needs to be able to speak those protocols to external servers. So I'm a bit confused about the claim of simplicity and how the Magma abstraction provided helps. Maybe an example.
Yeah, no, that's again a good question, right? So the way that it would do, the way that Magma does it, so for cases where we need, so Magma has two models, right? So one is like a Magma only deployment, in which case we don't implement S6A the way that the 3GPP standard exposes it. So it's all implemented through gRPC, and it's a protocol agnostic. It's a protocol agnostic implementation. So, for example, SubscriberDB, which is our HSS Lite, implements EAP functionality as well as Melanage, and so you can support both auth form factors within the same service. Now, if you have to federate to an existing core network where there's an operator who has a SIM, yes, we have to talk to the outside world. But even there, within Magma, we don't speak diameter, we don't speak all of the fields that 3GPP requires us to speak. It speaks gRPC within it, and it's a sort of the data model is the union of all protocols as opposed to having a different protocol for each generation. So a single service can support multiple generations of radio technologies.
Okay, so if I were to summarize, basically you make the network look like a 3GPP network to the UE, but under the hood, it's not a 3GPP network.
Yep, and it's the same service that speaks to various radio generations. So it's almost like an adapter model from like a object-oriented programming standpoint.
Okay, thanks from Jim. So I don't see any other questions in the chat. Serge, maybe?
Yeah, maybe I have one. I was very curious when I dig a little bit into Magma about a quite different note, which is about this decentralized wireless solution, which I believe might have some interest in some very specific environments. So if you could explain a little bit and maybe give some examples of practical deployment.
Yeah. So yeah, Helium is the largest decentralized, but there's also a couple others, Onyx Mobile and Pollen. So all of these are sort of the same mental model, which is that within the US and I think in parts of LATAM where Onyx Mobile is, there's spectrum available to like commercial entities like real estate owners like Starbucks, or like the biggest example I think for Helium is like this billboard sign owner company. And so they use like lightly licensed spectrum like CBRS, and they already have backhaul. So what they're doing is that they're deploying a fully distributed LTE network that is managed through a single orchestrator by Freedomfi, which is a company that I'm involved with. And they earn crypto tokens for building out this coverage. And a carrier, say, Dish or, GigSky, who's the one who's launched first, which is an MVNO in the US, is able to roam onto this network because of the integrations Magma offers into their HSS. So for the real estate owner, it's actually pretty cheap to deploy because they already have the vertical asset, they already have the power, and they already have the backhaul. And they're earning crypto tokens for running this LTE network that is managed by this neutral entity. And then for the carrier like Dish, who doesn't have coverage but has coverage obligations, it's a very fast way to grow out their footprint. For MVNOs like GigSky, I believe they have partnerships with AT&T and T-Mo, who are their roaming partners. The Helium network is cheaper. So as long as I think Helium is 60 cents a gig. So as long as they're able to get customers off the macro network, they also benefit. So for all the three parties involved, which is the real estate owner, it's a revenue stream that they didn't have. For the mobile operator or the MVNO, it's a cheaper network. And then for like the neutral host operator like Freedomfi, it's a way for them to have a business without actually building out a network with zero capex, basically.
Thank you. Quite interesting.
Yeah. There is actually a blog post that I wrote not too long ago. I can post it on the channel. So
yeah, either on the chat or the Slack channel or wherever. It would be nice.
Yeah.
Thanks. I see that there are other questions
Yeah,
coming.
there are a couple of others here. One from Luis Felipe. Okay, you kind of answered it in your presentation, but maybe you can be a little bit more specific here. Why has Magma decided not to be fully 3GPP compliant under the hood?
Yeah, so I think we're heavily inspired by what happened on the data center side, which is that terminate any sort of protocol awareness at the edge, and then run an x86 platform or like an ARM platform all over the network. So that way you get the composability that you need. Like, today your network needs a firewall, tomorrow it needs a load balancer. You don't need to like bring in an entirely new device. So that's sort of the model we want, which is that, okay, today it's a Wi-Fi network, tomorrow we want to upgrade to LTE. Day after we want to run a mix of both. Like, in fact, like some of our operators actually run Wi-Fi and LTE. And so there's a single way of running and operating such a network.
Okay. There was another one from Jim. I'm sorry, there's a bit of noise in the background now. Could you speak about deployments and how easy one can use Magma out of the box? How much expertise is needed on the adopters deployer side? And does Magma as an organization provide that kind of help or handholding as a service?
Sorry, sorry, my audio went out.
Okay, I'll say it again. I'll read it again here. Could you speak about the deployments and how easy one can use Magma out of the box? How much expertise is needed on the adopters deployer side? Does Magma as an organization provide that kind of help or handholding as a service?
Got it. Okay, so no, great question. So I think Magma, for various reasons, liabilities included, doesn't actually provide a prepackaged, it just provides the software bits. So there are vendors like Wavelabs and Freedomfi, who again I work for, who actually take those bits and package it and offer it as a shrink wrap solution. So that part requires a decent bit of understanding of like the various components, being able to like understand Kubernetes, deploy Kubernetes, all of those things. Once shrink wrapped, it actually is pretty easy to use. In fact, like plug and play is how the Helium network works, which is like they're basically people who know nothing about LTE who are like deploying radios. And I looked at the Helium site list. I think in the last week, there were 100 new radios that got deployed. So it's pretty plug and play once it's been shrink wrapped. But the step to shrink wrap is not that easy.
Okay, there. Another couple questions. I'll ask the second one first. Is it possible now to implement Magma completely using containers inside one computer or virtual machine?
Containers is, I think Tien can also talk to this, but containers at this point is just alpha. So with 1.7, it's alpha, but we're looking to make it better. But Tien, feel free to jump in here.
Yeah, of course. We also from EURECOM, we are working on that to help to deploy Magma VM in the container and the Magma access gateway in the container. So that is easier for the developer to set up a Magma environment.
Okay, there's one last question. Why NB-IoT is taking so long to be implemented? I guess that question of the NB-IoT support within the MME.
Yeah, I think Facebook, at least, which was primarily driver behind the development, is more interested in connecting people. And so NB-IoT was not a priority, but I think the EURECOM folks are helping.
Yeah, I mean, that is something, it was not really a priority for us either, because we're not doing the NB-IoT RAN. But you know, that it is being done now. So. So I don't see any other questions.
Raymond, there is one interesting on the Q&A from Serge, who is asking what kind of opportunities do you see for research purposes, especially for PhD students with academic environments? I think it might be a good transition.
Yeah, so I have a few ideas, so and feel free to jump in, Raymond and Tien. So I think for me, the big revelation with Magma in the last year, at least, is all of the Web3 and decentralization that's happening, right? So there's a lot of both money going into it, and with mid-band spectrum, it seems like, you know, real estate owners seem to have a significant advantage in cost structure for deploying a network compared to like a mobile carrier. And so that market exists. So in that market, I think identity is still very centralized, and, you know, physical SIMs are actually a pretty hard distribution problem for, you know, a fully decentralized network. So there's a lot of work that and research opportunities around decentralizing identity that can sort of benefit from this network. And also, like, you have a real world, like, large network. It's deployed in like 45 states in the US at this point. So if there is anything that is promising, you know, the Magma project gives you a way to reach those 45 states. So it's actually a pretty nice way to validate it. The second one, and I think this is more on the networking side, is that mobility has inherently been implemented in the network and the application. And a lot of what Quick and the new internet protocols that, you know, all the web apps speak are transparent to IP mobility, because they want to support like people moving from cellular networks to Wi-Fi, where, you know, handover is going to be challenging. So just figuring out what's the right intersection point between mobility awareness that needs to be at the network and mobility awareness needs to be in the application, that would also be a super interesting challenge. But those are two top of mind ideas, which I think have legs within Magma at least. I don't know if Raymond.
I don't really have anything to add. I think, you know, aside maybe from the fact that you have a full suite, software suite that is ready to be deployed and can be used for campus type networks. So any type of research infrastructure on a campus is, you know, would be, it's a good way to do it in my opinion, particularly because it also combines the Wi-Fi aspect in there, which is nice.
Great point.
Okay, I guess, Raymond, that
yeah, I think we're done here in
yes.
time-wise.
Yes, and well, again, gratitude to Raymond for organizing this very interesting program. Again, Magma is a wonderful project, and we have seen a small piece of it, so I get that it will give you even more interest to look in more detail. Thanks, Amar and Tien, and as we do usually, I would like just to call for your participation for the next networking channel program in 2 weeks from now, same time. And as you see, it will be of a different note. It's going to talk about 6G EU and US programs, and we will have this being organized thanks to Didier Bourse from Nokia, I would like to acknowledge here. And we have participation both from 6GIA in Europe, as well as NECG and ATIS from the US. So we give you a rendezvous in 2 weeks from now. important. This will be the last program of the networking channel for this semester. We will have this summer break as usual, and we will come back in September. Thanks again to you all. As you know, this has been recorded and will be available on our YouTube channel, and we will collect the slides from the panelists and post them on the website. Thanks, and take good care of you. Thanks again. Bye-bye.
Thank you. Bye-bye.
Thank you. Thanks.